Hello everyone, welcome to our presentation. My name is mkitchen. I'm with Adams Environmental Inc., a woman-owned small business located in San Antonio, Texas, who specialize in environmental consulting services and GIS. I'll be doing this presentation with Gian Villarreal from Seagull PME and Michelle Tanner from Second Nature, and they'll give themselves a little introduction later on. Today we're going to talk to you about rethinking GIS efforts to expand MS4 programs. So let's start the presentation by telling you what I'm going to be telling you about. Before we do that though, let me define a couple key terms for you. MS4 stands for Municipal Separate Storm Sewer System. I'm sure most of you watching the presentation are familiar with that term, but just in case, it's basically the storm drain system. Municipalities are required to have permits for their storm drain system, and under that permit they regulate construction sites, stormwater runoff, and other discharges into receiving waters. GIS stands for Geographic Information Systems. Simply put, GIS is the geographical representation of data. If the data you're using has a location, GIS can be used to map, analyze, and assess it. Okay, so let's start with an overview of GIS and how it can be used to support MS4 systems. Then we'll tell you about how you can capitalize on existing GIS data. Whether through your own system or outside sources, there's a wealth of GIS data out there in the world that can be used to enhance your current practices. Lastly, we'll expand on commonly used GIS applications and show you some case studies involving public education, coordinated watershed approaches, implementation strategies, and reporting. First, let's discuss the most common applications for GIS. These are ways you're probably already using GIS in your office in one way or another. Field collection support tools. How are you actually capturing and collecting this data out in the field on site? Data management. What are you doing with this collected data? How is it being organized on your server? Maps for reports. This is the displaying of data in a way that conveys the purpose you're trying to present to the reader or user. With current GPS technology and applications, it's become a whole lot easier to collect data, including locations and conditions of systems. You can capture any sort of attribute you want nowadays. You create a sort of database in the office, and then when you get out in the field, you can fill in that information on the fly. This can be used for such applications as illicit discharge detection and elimination, construction site runoff control, post-construction runoff control, and pollution prevention or good housekeeping. Here's an example of how we used to do things. You have a clipboard and a piece of paper where you fill out information depending on what site you're at. These are examples from Fair Oaks Ranch, but I'm sure you use something similar. Well, nowadays you don't have to use these anymore. Your tablet or phone can replace these, as you'll see in the next couple slides. It streamlines the process a whole lot so that when you get in the office, there's no data entry. It's just straight from your electronic device to your computer. The great part about GIS and GPS mobile applications these days is they can be used on any sort of electronic device. Whether you're using a phone or a tablet, Android or Apple, you're guaranteed to find an application that'll suit your needs. Here's an example of a data collection application I made using Esri's collector software. On the left side of the screen, you see a form you may have used in the past to capture information about an illicit discharge. You see characteristics on the right like odor severity, color severity. Well, on the right side, you can see how this can be captured digitally instead. You see the map showing your location where you can add a point. It automatically takes down the date and the time. And then with things like inspector and the odor and the color, there's drop-down menus so you can click those things right there for easy input. The great part about capturing the data electronically in the field is that it's automatically synced to the cloud as you collect it. When you get back into the office, the data is already there and your database is ready to go. It also provides a great way to organize your data. Gone are the days of file cabinets with endless amounts of paper. You have the data right there with a few clicks away at your fingertips. It's also a great way to be able to provide access to the public. It's interactive, informative, and provides a great educational value. So here's where it gets exciting, for me at least. So you've gone out in the field, you've collected your data, it's automatically synced back into your database at the office. Well, without getting too far into the weeds, Python is a scripting language behind of what most of GIS does. So what I've done is created a script where it takes the data you've collected in the field and it takes data from outside sources like we talked about in the first couple slides there. You can take data from other websites, from other servers, and it pulls them in to what you're doing. So the script gathers all that data and then it takes it and automatically makes the map and fills in blanks in a report. So the automation of reports becomes pretty simple using all those methods. It's a whole lot to get into for this presentation, but if you have any questions about it, let me know because it's pretty exciting stuff. Another exciting avenue that the GIS world has been moving to is web-based mapping. What you see here is what's called a story map. This one was made by the Nature Conservancy, but when the user clicks right or left, they can scroll through these different maps showing nature-based climate solutions and what they do and how they're effective. This is the story map example, but there are other things like just, when you go to a website and you go to their maps and you can turn on and off layers and view things how you like them, print them out, do whatever you need, even some spatial analysis, create a buffer around this, find an intersection here or there. Those kinds of things are doable all on the web now for people who don't have much experience with GIS. So there's a lot of different ways you can convey information, and it's pretty exciting. What you see here is a sign from my old stomping grounds of San Marcos, Texas. This sign is about biofiltration areas, and there's a diagram down there to show you how they work. And if you look on the bottom left, there's a QR code that says Scan Me. When the user scans this, it takes them to a website where they can learn more about the subject. While this particular example isn't about GIS or mapping necessarily, it serves the purpose of showing what you could do with something like this. Maybe the user scans that and it takes them to a story map that explains biofiltration in different areas, or maybe it's a web map where they can view different biofiltration areas around San Marcos or around Texas. It's just another exciting avenue of how you can convey information to people to show them what you're doing and how it's all working for you. Now I'm going to turn it over to John, who's going to present some case studies to you guys and expand upon the base knowledge that I presented here. Thank you.
Thank you, Matt. My name is John Villarreal. I'm the Water Practice Principal for Seagull PME. We're a small Hispanic-owned firm based in New Braunfels, Texas. And our water services team provides civil and environmental engineering consulting services, primarily focused on watershed management and including stormwater, water quality, stream restoration, and flood control. Matt walked us through commonly used GIS applications, how these are often used for MS4 program support, and some of the exciting new tools being used with GIS. Now I'll be going through the first of two case studies that provide examples of how GIS supports MS4 compliance, how to capitalize on existing data, and also how to expand on GIS efforts. This first case study is for a project that I worked on with the San Antonio River Authority and that used GIS data and tools to assess impacts from development on receiving waters and on the storm drain system. The city of San Antonio, as part of their planning efforts, had identified regional growth centers where high rates of growth were expected over the next 20 years. SIR has completed 3 assessments to evaluate the impacts of development on flooding and on water quality. The slides that I'm presenting are primarily focused on the assessment that was completed for the Rolling Oaks Regional Center, so one of the 3 assessments. An image of the center is shown here on the slide, so you can see the area that we studied. The reason that I selected this project was that it includes interesting ideas on how GIS can be used to help with multiple things such as public education and outreach, also to quantify impacts from best management practices and other MS4 mitigation measures, and also as part of public tools that can be provided to support these. This city has also been working on an asset management effort as a result of a consent decree. And so there's a lot of good information coming from that effort towards the MS4 system, or understanding of the MS4 system. Sarah has developed really good tools to help provide information from the study results to the public. And I'll go through some of this as well. The GIS data used included land use data, impervious cover, information about the storm drain system, and also hydrologic data. The next step in this effort was to assess how runoff and pollutant loading would change over time. We used GIS software to do a comparison of existing land use and impervious cover and compare these to future conditions with the expected rates of development. You can see on the left a graphical representation of this comparison and resulting GIS image where the rates of change of, in this case, impervious cover are shown. So these top two boxes are existing conditions and future conditions. And on the bottom right is the change in impervious cover expected through that period of time. You can see the dark blue are the areas where the highest increase in impervious cover can be seen. And so that's one of the interesting things that you could take from this analysis, is where those hot spots or priority areas of concern are located. The next step in the effort was to identify potential opportunities for implementation of best management practices. So this portion was a coordinated effort between field and also GIS desktop assessments. So one of my colleagues with TBG was working with Sarah to do that field portion. They drove the entire area to identify potential locations for implementation of BMP projects. This was also informed by the assessment of impervious cover change and the prioritization or evaluation of those hotspot areas that I mentioned. A separate effort was performed by my team to assess the areas where non-structural best management practices such as street sweeping, pet waste pickup, and other public education and outreach efforts could be implemented. And you can see these on the images. So we have, in one of the images, you can see the structural efforts that were identified. You can also see the non-structural, and these were proposed with specific locations, and the drainage or treatment areas were evaluated to identify the region that would be treated. The GIS data and analysis that were shown in the previous slide were used in a number of different models, including flood models, watershed pollution transport models, and a spreadsheet analysis that was done for trash. Here on this slide, I'm showing an image that represents the trash results. I selected trash because the analysis for this one was tied directly to the GIS results, so it shows the clearest link. But for this trash analysis, trash generation rates were assigned to different land use areas for those existing and future conditions. And then each BMP was assigned a treatment area and rate of treatment efficiency. And these were based on scientific studies that had been performed on other existing systems. And these evaluated the effectiveness of different BMPs to capture or reduce trash. So this image shows the results of that analysis. The different colors represent different rates of reduction or capture by the subwatershed. And so, for example, the dark blue areas showed little trash reduction for the BMPs that were implemented. And that was between about 0 and 10% versus the yellow areas where trash reduction went from around 50 to 70% and in some cases even higher. And then the other colors show something in between. So similar maps were created to show the results of analysis for the local and regional flooding and also for bacteria, nutrients, and other pollutants. But again, I am showing the trash one because it has kind of the clearest link to the GIS information that was used. In the next couple of slides, I wanted to show how Sarah is using the information provided from these studies to educate and inform the public about the potential impacts of development on flood control, water quality, and also on mitigation efforts for these. So Matt had mentioned in his slides web mapping and also story map tools. The images shown here are from a story map that Sarah created using GIS software to tell the story of one of the Regional Growth Center projects. Here are a couple of the images from that map story, and they were using images and maps to summarize the impacts on trash loading here on the left, and on the right on stream flow velocities. These are similar to some of the maps that I had showed on previous slides. But I really like these images, especially this one here on the left that uses the different size trash cans to represent different amounts of trash that were shown in different scenarios. I thought that was a good way to visualize the impact of the different scenarios. Then on the right, you can see in more of a map representation areas that were impacted by different stream velocities due to the changes in impervious cover. This is another image that I wanted to show because I think it provides an interesting example of a couple of ways that GIS can be used to support MS4 programs. This example shows a GIS Web Map that Sarah created to show the BMPs that they have funded through some of their programs and the impact of those devices. So you can see in the map on the screen the location of the BMPs that have been funded through these programs. And then to the right of that map, you can see the impact of those BMPs on volume, on sediment, and also on bacteria. And so you can see the benefit of the systems that have been implemented. One of the ideas that we previously discussed in the San Marcos BMP that Matt went over about the QR code that could link to a web page and the impacts of that BMP could be assessed. Well, this is a really good example of a web page that QR code could link to, right? So imagine if you're out in the field, you link to that QR code and it takes you to this screen where it shows the relative location of that and the impact that that system has had. And so with that, I'll turn it over to Michelle Tanner with Second Nature, who is presenting on the second case study to show how a flood-controlled district is using GIS to expand their program.
Thanks, John. Hey everyone, I'm Michelle Tanner, and I'm a senior scientist at Second Nature. Second Nature Software builds enterprise cloud stormwater management and compliance software that's purpose-built for municipal stormwater managers. We use GIS technology to support municipalities in managing stormwater assets, measuring program effectiveness, streamlining regulatory MS4 compliance, and planning healthier cities. I am going to go over a quick case study from one of our customers in Arizona, Yavapai County. The Yavapai County MS4 boundary is unique in that it's comprised of 16 different segments and contains 148 mapped outfalls along roadside drainages. At least 50% of these outfalls must be visually inspected annually during dry and wet conditions after rain or from snowmelt. Additionally, the permit requires the seasonal collection of water samples from selected outfalls for the monitoring of E. coli. Historically, Yavapai logged their outfall inspections on paper forms in the field, then updated their Excel database after returning to the office. Field photos were also a hassle to manage. Everything was managed in separate photo albums, and it was difficult to remember which photo belonged to which site. When it came time to compiling their annual report, they spent countless hours manually conducting analyses in Excel and creating reports. Yavapai County's goal was to not only digitize their field data collection, but also adopt an objective methodology that would allow them to demonstrate their stormwater program's performance to their regulator in a simple and repeatable way. So, their first step was to gather all GIS data that was relevant to their stormwater program. They took their stormwater drainage information, local land use, local rainfall, and soil information, and put that into their new stormwater management software. From that, they were able to quickly estimate average annual stormwater runoff volumes and pollutant loads using a GIS-based system with just a click of a button. They didn't even have to open their Excel or Access databases or write a single line of code. These results were then aggregated to their sub-watersheds within their jurisdiction, so they could quickly identify priority watersheds. With their outfalls then loaded into their mapping platform, now they could also pinpoint the outfalls that drain these high priority areas. With all of their stormwater program data finally in one location and using GIS software, they were able to unlock efficiencies in the field, in the office, and in their reporting. Using their new system, they were able to not only use their local program data, but also pull in publicly available national data sets to provide standardization and pretty quick onboarding. Yavapai County was actually up and using the software within a matter of weeks, a pretty good indication that switching to a GIS-based approach doesn't need to be a long and complicated process. Because all of Yavapai County's field inspection forms were now digital, this eliminated entire QA/QC steps in their field's standard operating procedures. They no longer needed to transcribe datasets into an Excel spreadsheet and didn't have to go through the grueling process of QAing outfall photos on a camera. It was already uploaded to the cloud and associated with their historical records. Besides the field data collection and hydrologic modeling components, their new system also allowed them to generate their annual report automatically with the click of a button. This saved their team countless hours that they spent compiling PDF documents. The system also provided tools for them to help manage and report on all minimum control measures in their stormwater permit. Yavapai County's MS4 is now running a digital performance-based compliance program through the use of GIS. The ease, speed, and versatility of their mobile inspections led to a 210% increase for their outfall inspection sites. This efficiency allowed their team to now focus on other things that mattered in their county, like the maintenance of culverts for flood protection. Their GIS modeling capabilities not only provided them with a way to track average pollutant loads, but they can use that same model to also predict the effectiveness of planned structures and stormwater projects across the county.
Thank you, Michelle. With that, on behalf of Matt, Michelle, and I, we'd like to say thank you to the hosts and also the sponsors of this conference. Here's our contact information if you would like to reach out to any of us or find out more information about what we do or any of these projects. And now we'll be available for questions. Thanks again.